Some of the world's most intense rivalries are unfolding right now on Earth through conflicts, alliances, sanctions, and military strikes. But hundreds of kilometers above all of that, astronauts from rival nations still work together, sharing the same space station. The question is, how long can that last? Because as global tensions rise, the fragile cooperation that built modern spaceflight is starting to feel increasingly rare. Let's go back to where this started. The first space race was born from geopolitical rivalry. The United States and the Soviet Union didn't push rocket technology forward because they were passionate about science. They did it because whoever controlled orbit controlled the strategic high ground. A rocket capable of launching a satellite into space was also capable of delivering a nuclear warhead across continents. From the very beginning, the stars were tangled up in politics. And the question worth asking, the one this video is really about, is whether the political fractures forming right now on Earth are capable of permanently breaking something humanity spent decades carefully building together up there. Something unexpected happened once the Cold War ended. Former rivals began actively cooperating. The International Space Station stands as one of the most unlikely achievements in modern history. The engineering took decades and the coordination of 5 space agencies. The political achievement was just as improbable. Rivals who had spent decades in a nuclear standoff agreed to share a roof in orbit. The United States, Russia, Europe, Japan, Canada, nations that had spent decades pointing nuclear weapons at each other, agreed to share oxygen, water, and living quarters 250 miles above the Earth. American astronauts launched on Russian Soyuz rockets. Russian modules provided critical power and propulsion to the American segment. The arrangement held because it was practical, and it became historic because it held. What the ISS represented, at its core, was proof that cooperation could outlast rivalry. Even during periods when relations between Washington and Moscow deteriorated on the ground, the crew rotation schedules continued, the hatches stayed open, and science kept happening. Space had carved out a lane that geopolitics couldn't fully reach. The question we're now confronting is whether that lane can survive a world where geopolitical competition is actively reshaping who cooperates with whom and on what terms. In July 2025, NASA and Roscosmos held their first in-person leadership meeting since 2018. The result was an agreement to extend ISS cooperation through the end of 2028, with joint planning already underway for a controlled deorbit by 2030. Russian cosmonauts will continue flying on SpaceX's Crew Dragon. NASA astronauts will continue boarding Soyuz. On paper, the partnership holds. That agreement, though, exists against a backdrop that has shifted considerably since the ISS partnership was first built. Russia's invasion of Ukraine triggered sweeping Western sanctions. Roscosmos lost the revenue it had earned from selling Soyuz seats to NASA, seats that had reached $90 million per launch by 2020. Technology sharing arrangements collapsed. Joint science missions that had been in planning for years were quietly shelved. Russia's Luna 25 spacecraft, its first lunar mission since 1976, crash-landed on the Moon's surface in 2023, a failure that some analysts connected directly to the loss of European components following sanctions. Russia's space agency was already contending with budget pressures before the war, and the loss of Western contracts compounded those strains. Some of that gap has since been filled by closer alignment with China's space program, signaling how geopolitical realignment on Earth is quietly producing new partnerships in orbit. Meanwhile, regional conflicts across multiple theaters are forcing nations to make harder choices about which partnerships they can maintain and which technology they can share. The ripple effects don't announce themselves dramatically. Launch contracts quietly shift, technology partnerships narrow, and science timelines stretch without headlines. The signal is subtle, but it's consistent. Geopolitics has always influenced space. The open question now is whether the cooperative infrastructure humanity built during a more optimistic era can hold under the weight of a much more fragmented world. The satellites orbiting Earth right now form the invisible architecture of modern civilization and modern warfare. GPS was built by the U.S. military. The same signal guiding a delivery driver through traffic is also guiding precision munitions on a battlefield. The same satellite imagery tracking a hurricane's path is tracking troop movements. And the same communications networks keeping remote communities connected are enabling drone operations in active conflict zones. We saw this dynamic play out in stark terms in Ukraine. Commercial satellite imagery debunked Russian military narratives in real time. Starlink terminals provided battlefield connectivity that changed tactical outcomes. And by 2025, Chinese companies were supplying satellite imagery to Russian forces, a civilian commercial service feeding a live military conflict. This dual-use reality is what makes space cooperation fragile in ways it has never been before. When a satellite serves military functions, every nation with an adversary starts looking at that satellite differently. Cooperation becomes harder to sustain when the technology being shared can be turned into a strategic advantage against you. In 2021, Russia conducted a direct ascent anti-satellite missile test, destroying one of its own defunct satellites and generating a debris field of over 1,500 trackable fragments that forced ISS crew members to shelter in their return vehicles. China conducted a similar test in 2007, and the United States has developed its own counterspace capabilities. The major spacefaring nations have already demonstrated a willingness to treat orbital assets as military targets, and the debris those tests generate threatens every nation's satellites without distinction. Every kilogram of debris in low Earth orbit is a shared problem, and the nations best positioned to solve it are the same ones pulling further apart on the ground. We're already seeing this in practice. GPS jamming and spoofing events have become near-daily occurrences in contested regions: the Baltic Sea, the Middle East, parts of South Asia. In June 2025, during Israeli strikes on Iranian military infrastructure, one of the explicit strategic goals was to degrade Iran's command and control systems, including space-reliant communications. Space assets weren't directly targeted, but the logic was clear: degrade the infrastructure, degrade the response. When the infrastructure powering civilian life is the same infrastructure providing military advantage, every decision about cooperation carries a strategic dimension that pure science never did. Today's space race spans multiple continents, a dozen independent launch programs, and 2 competing lunar coalitions, at a scale the original Cold War rivalry never approached. On one side, the U.S.-led Artemis coalition has grown to 56 signatory nations under the Artemis Accords, a framework built around transparency, interoperability, and cooperative resource use on the Moon. Artemis II, a crewed lunar flyby, is scheduled for April 2026. Artemis III, the first crewed lunar landing since Apollo, is targeting mid-2027 at the earliest. Though NASA's Safety Advisory Panel has raised concerns about SpaceX's Starship landing system being flight-ready on that timeline. On the other side, China and Russia launched the International Lunar Research Station Initiative in 2021, which has since grown to 13 partner nations, including Pakistan, Belarus, Egypt, and South Africa. China has pledged to land its first astronauts on the Moon by 2030 and has a track record of meeting its stated timelines. In August 2025, China successfully completed a touchdown and ascent test of its Lanyu crewed lunar lander, a significant technical milestone. Chang'e 7 is set to survey the lunar South Pole in 2026. The divide is remarkably clean. With the exception of Thailand and Senegal, no country has signed both agreements. The Artemis and ILRS coalitions represent competing visions of who sets the rules for humanity's expansion beyond Earth, and whose infrastructure becomes the default standard. India is expanding its own capabilities independently, with Gaganyaan, India's crewed spaceflight program, preparing its first human missions, and Indian astronaut Shubhanshu Shukla having reached the ISS aboard the Axiom 4 mission in July 2025. The result is a space environment with more participants, more overlapping interests, and far less shared governance than at any point in history. More partners mean more competing interests to reconcile, and fewer shared frameworks to reconcile them with. The case for continued cooperation is concrete. Shared costs reduce the financial burden on any single nation. Shared expertise compresses timelines that would otherwise take decades. and a stable orbital environment with coordinated debris management, collision avoidance, and spectrum allocation requires every major spacefaring nation at the same table. The bigger risk is fragmentation along geopolitical lines, and once that sets in, reversing it becomes structurally very difficult. If the Artemis and ILRS programs develop in complete technical isolation, different navigation standards, different communications protocols, different resource extraction frameworks, then the lunar South Pole, where water ice deposits make permanent habitation possible, faces the prospect of incompatible infrastructure from competing blocks operating in the same small geographic area. The handful of ridges near the South Pole that receive near-continuous sunlight are limited. Multiple programs converging on the same sites, operating under different rules, with no shared deconfliction framework, is a scenario that analysts are beginning to take seriously. Fragmentation in orbit raises the real risk that a misunderstanding between satellites, between ground stations, between nations interpreting the same event differently, escalates into something far harder to walk back. For decades, space held a quiet, almost improbable status as one of the few places where cooperation survived rivalry. Astronauts from nations whose governments could barely speak to each other shared meals, shared experiments, and shared the view from 250 miles up. That era is not over. The ISS agreement through 2028, the continued cross-flights, the ongoing science, these are real, but the structural conditions that made that cooperation possible are under genuine strain in ways they weren't a generation ago. The strategic value of orbit is rising, the dual-use nature of space technology is deepening, and the coalitions forming around lunar exploration are hardening along geopolitical lines, all at the same time, all feeding the same tension. And the conflicts unfolding on Earth, from Eastern Europe to the Middle East, are demonstrating in real time how quickly space infrastructure becomes part of a military calculation. The decisions being made right now about which partnerships to maintain, which standards to adopt, which coalitions to join, will determine whether space remains a domain where shared progress is possible or becomes another arena where the divisions of Earth simply continue at a higher altitude. Whether the next giant leap for humanity happens together or separately depends on the choices being made today. And most of those choices aren't being made by astronauts. They're being made by the same governments whose tensions we're watching unfold right now on the ground.